counting. I know we've learned how to count a long time ago, but we're going to look at it a little differently. So suppose you are dining at a restaurant and there you have 3 different appetizers, 8 entrees, and 6 desserts. How many different ways can you plan out the meals? Well, we could make a lovely tree diagram and count all the different ends, all the different options, write them all out. That would take a while. But what we're going to use is what is called the fundamental counting principle. And it just says that if there's so many ways to do event A and so many ways to do event B, then they're going to occur in this times this ways. So the number of appetizers was 3, number of entrees was 8, number of desserts is 6. So I'm going to multiply them all together and get 144. You know those commercials when they say there's so many thousand possibilities? This is how they figure out the number of ways you can order from Baskin Robbins or whatever. Let's say we have license plates. Okay, so this is the Save the Wild Animal license plates, which gives Pennsylvania zoos $15 for each plate sold. These plates have the 2 letters P and Z, followed by 4 numbers. When plates like these have all been purchased, additional plates will replace the final digit with a letter other than O. What is the maximum amount the zoos could receive? So let's first think about this. Okay, so on this license plate, the first 2 letters are set, right? P and Z. So there's only one option. Then 4 numbers. So there's 10 possibilities, 10 possibilities, 10 possibilities. And then the last one is going to be all 10 of those letters, to all 10 of those numbers, or replace with a letter other than O. So there's 25 of those. So 10 plus 25 would be 35 options for the last number or last digit. And we would multiply all those together. The ones really don't matter. 10 times 10 times 10 times 35 is going to be 35,000 combinations of plates. If they sell all of those and they're making $15 a plate times 15, then the zoo makes $525,000. Suppose a person planning a banquet cannot decide how to seat the 6 honored guests at the head table. In how many arrangements can they be seated in the 6 chairs? So when I first pick the first seat, there's 6 options. Then I've already placed somebody, so there's 5 options left. Then there's 4 options. Then there's 3 options. Then there's 2 options. And then the last person just gets to sit. So 6 times 5 times 4 times 3 times 2 times 1. 720 different ways. Now this product, 6, 5, 4, 3, 2, 1, occurs so frequently, we use special notation. It's called a factorial. 6 factorial, and it's an exclamation point, is 6 times 4 times 6 times 5 times 4 times 3 times 2 times 1. 4 factorial will be 4 times 3 times 2 times 1. And 0 factorial would just be 1. I mean, that doesn't even make sense. And this is in the calculator, by the way. So there's a couple of ways we can get there. The easiest way is, so let me say I wanted to do 6 factorial. I'll do 6, and press math. And this is over here in probability. And there's an exclamation point. And it does it for us. Alright, so let's see how this one's going to work. Suppose the planner knows that 8 people feel they should be at the head table, but there are only 6 places. No, this changes it. So there are 8 people for 6 places. That changes things a little bit. It would be 8 for the first seat, then I have 7 options, then I have 6 options, then I have 5 options, 4 options, and 3 options. Right? Which would be 8 times 7 times 6 times 4, 5 times 4 times 3. Because we cut off the last 2 options. So this would have been the same as doing 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 2 times 1. And so that's like having 8 factorial divided by 2 factorial. And the way I'm going to get that 2 is because there's 2 people that aren't getting seated. So it was 8 factorial divided by 8 minus 6 factorial. This is called a permutation. Like I have to sneeze. Oh, bless me. Okay, so we have 8 things placed 6 ways. So 8 pick 6. We're 8 people, we're only picking 6. So 8 pick 6 is a permutation. It's 8 factorial divided by 8 minus 6 factorial. Or here it is in generic terms. It's n things, and we're only picking r number of them. So let's see. In how many ways can a president, vice president, secretary, and treasurer be selected from an organization with 20 members? So we have 20, and we're picking only 4. So I could use this formula. I'm going to show you a couple of ways to do this. That would be 20 factorial, and then it's n minus r. So 20 minus the 4 divided by 16 factorial. It'd really just be 20 times 19 times 18 times 17. It's pretty easy to do by hand, but I also wanted to show you could do it in the calculator. So 20 factorial divided by 16 factorial. Woo! It's a lot of different ways I could set those kiddos up. There's also an option, I don't know if you saw it when we were in the math probability section. Do you see the NPR? It asked me how, so it's got a place for me to put the 20, and we're picking 4 people, and it gives me the same answer. So there's a couple of ways to do it. Now, what if the order was really, really, really important? I apologize. The order was important here. Where they were positioned is important. But what if it's not? That is actually called a combination. When we're not caring who got picked president or whatever, or who got the first seat, or what position the license plates are in. And it's called a combination. And it has a different formula, which if you do not have a calculator, you could use this formula. It's n factorial divided by r factorial, and then the difference between them factorial. But there's also a place in the calculator for combinations. Let's see an example that a combination would be used. An auto dealer is offering any 4 of 6 options at one price on a specially equipped car being sold. How many different choices of specially equipped cars do we have? Notice that the order is not relevant. It's not who's seated where. It's not who's getting what position. Order doesn't matter. Order doesn't matter. And so this is going to be, we've got 6 options and we're choosing 4 of them. I like to think of the P for being picky about order. If I'm not picky about order, I'm just choosing things. So under math, probability, there's an option for NCR. Choosing from 6, we're choosing 4. And there's only 15 ways. 6 and 8 women are qualified to serve on a project team to revise operational procedures. How many teams can be formed containing 3 men and 3 women? Does this one matter what order we pick them? No. So I'm taking 6 men and I'm only choosing 3. And 8 women and choosing 3. So I'm going to multiply those 2 together because it's an and, not an or. Whoops, I hit the wrong one. It's number 3. Okay, so 6 choose 3 times math, probability. 8 choose 3. And it gives me, there is 1,120 ways. Little Caesars stated that for $9.95 you could get 2 medium pizzas, each with any of 0 to 5 toppings chosen from 11 that are available. The commercial asks the question, how many different pairs of pizzas can you get? So if the pizza has a thin crust, and the second way if it has a thick crust. So let's start with thin crust. So these are ors, right? We could have, from the 11 toppings, somebody chooses none of them. Or the 11 toppings, somebody chooses 1. Or from 11 toppings, we choose 2. Or from the 11 toppings, we choose 3. Or from the 11 toppings, we choose 4. How many can we choose? 5. So, or from the 11 toppings, we choose 5. So, math, probability, probability, I keep doing that. So 11, choose 0, arrow over to do the plus. 11, choose 1, plus 11, choose 2, plus 11, choose 3, plus 11, choose 4, plus, see, I would not want to do this by hand. That would take so long. 11, choose 5. And we get that there's 1,024 ways to do a thin pizza. Well, how many ways would it be for the thick crust? It's 1,024 ways. So if we get a thin crust and a second one has a thick crust, the and would mean that we'd take the 1024 times 1024 for the 2 medium pizzas. 1024 times 1024 gives me 1,048,576. That's 1,048,576 different ways to order that Little Caesars pizza. Suppose a batch of 35 CPUs has 10 defective CPUs. In how many ways can a sample of 15 from this batch have 5 defective CPUs? So if 15 have 5 defective, that means we have 5 of the 10 defective, and that means that the other 10 of the 25 good, because we have 35 total. So that's 10 choose 5 and 25 choose 10. Times, because we want these both to happen at the same time. It's not an or. We're choosing 5 bad ones and 10 good ones. Woo! That's a lot of different ways.